Okay, class, we're on section 1.2, fractions and algebra. Okay, objective 1, we want to convert between mixed numbers and improper fractions. Okay, we have these rules here for converting a mixed number to an improper fraction. We need to multiply the denominator of the fraction by the natural number and add the numerator to this product. Place the result from step 1 over the denominator of the original mixed number. So let's go through this step by step. Okay, the first thing you should always know whenever you're converting a mixed number to an improper fraction is that your denominator stays the same. So your denominator would stay 5. Now we need to find the numerator. And this is how we would go about finding the numerator. We would take this natural number here multiplied by our denominator. So that would be 7 times 5. And we would add the numerator. Now our denominator still is 5. Now for our numerator, we follow the order of operations. We know multiplication comes before addition. 7 times 5 is 35 plus 3. And 35 plus 3 is 38 all over 5. Okay, now we come down here. It says converting an improper fraction to a mixed number. We're going to do the reverse of what we did earlier. It says here, number 1, divide the denominator into the numerator. Record the quotient, the result of the division, and the remainder. Write the mixed number using the following form: the quotient, the remainder over the original denominator. Okay, so now let's talk about an improper fraction for a minute. Improper fraction means this: either your numerator is greater than or equal to your denominator, which we have here. So our setup is to take our denominator, which is 9, and divide it into our numerator, which is 76. So we say 9 goes into 76 8 times. 8 times 9 is 72. 76 minus 72 is 4. So we will have a remainder of 4. Now, we have to rewrite this as a mixed number. Now this is how this will go. This number here is considered to be your quotient. So this is your 8. This will be your natural number. Now we need to find our denominator. Our denominator stays the same, which here is 9. And our numerator is the remainder. So it's 8 and 4/9. Now we scroll down here to the next page. Now I took the liberty of filling in some of these definitions. It says here, a prime number is a natural number greater than 1 whose only factors are 1 in itself. Okay, now we want to list the first 10 prime numbers. But before we do that, I want to talk to you about these factors these numbers that have factors of only 1 itself. Now, they said numbers greater than 1. They are not talking about decimals or fractions. That's what this is called, natural numbers. Okay, so now let's take the number 5. When we say factors, we're talking about two numbers multiplied together, or numbers multiplied together that would give you this number here. So the factors of 5 are just 1 and 5, or 1 times 5. That's the only way you could get 5. But let's take a look at a number like 10. Now 10, yes, we could get the factors of 10 as 1 and 10, but we know there's two other factors of 2 and 5. Now 1 times 10 is 10 and 2 times 5 is 10. So this is why this is not a prime number and this is. This has only 2 factors. This has more than 2 factors. So this is a prime number. Now we go here and start listing our prime numbers. Remember, 1 is not a prime number because its number is greater than 1. So our first prime number is 2, then 3, then we already know that 5 is 1. Then we have 7, we have 11, we have 13, we have 17, 19, 23, and 29. Let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so these are your first 10 prime numbers, but the prime numbers go on forever. Okay, now, if you notice here, 2 is the lowest prime number, and it's also the only even prime number. Any other even natural number is not prime, just 2. Now, a composite number is a natural number greater than 1 that is not a prime number. Expressing a composite number as the product of prime numbers is called the prime factorization. Now, just looking at this definition for composite, the number 10 fits this description. It's a natural number, it's greater than 1, and it is not prime. It's not a prime number, so that is considered to be a composite number. It has more than 2 factors. Now, if we wanted to write this composite number with only prime factors, this is called prime factorization, or only prime numbers, which we will go through here. Now we have the number 240. We want to write 240 with all prime numbers. So let's break this up. We know 2 factors of 240 is 10 times 24. 10 times 24 is 240. Now we could break 10 down to 2 times 5. 2 is prime and 5 is prime. I like to circle it just to show that I'm done with that leg of the problem. Okay, now we come to 24. Now with 24 we could do 6 times 4. 6 breaks down to 2 times 3, and 4 breaks down to 2 times 2. So 2 is prime, 3 is prime, 2 is prime, and 2 is prime. So now we're going to write out this prime factorization. Now what I like to do is write from the smallest to the larger numbers. So we have 4 2's, and we also have a 3 and a 5. And when you multiply these numbers, it will give you 240. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48, times 5 is 240. Now, since you all are using MyMathLab, this may be an acceptable answer, or you may have to write the answer like this in exponential notation. So what we will have to do here is we have 4 2's, so we'll write that as 2 to the 4th power times 3 times 5. So either one of these is the correct answer. So when you get on MyMathLab, try this answer first. If this doesn't work, then try this answer here. Okay, now we scroll down to objective 3. It says reduce or simplify fractions. It says reducing a fraction to its lowest terms. Write the prime factorizations of the numerator and the denominator. Divide the numerator and the denominator by the greatest common factor, the product of all factors common to both. Okay, now we start with example 4. It says reduce each fraction to lowest terms. So first thing that we need to do is to break the numerator and denominator down to its prime factorization. So we would take the number 42, and 42 breaks down to 6 times 7. 7 is prime, so we circle that. And 6 breaks down to 2 times 3. 2 is prime, and 3 is also prime. So our prime factorization of 42 is 2 times 3 times 7. Now we want to take 15. 15 breaks down to 3 times 5. 3 is prime, and also 5 is prime. So the prime factorization of 15 is 3 times 5. So now let's take this fraction, 42 over 15, and it's equal to 42 breaks down to 2 times 3 times 7. 15 breaks down to 3 times 5. Now the only thing they have in common is 3. So those simplify out, and you would be left with 14 over 5. And you're done. Now we look here at B. Now we take the prime factorization of 35, and also the prime factorization of 50. 35 breaks down to 5 times 7. 5 is prime, 7 is prime. So we will have 5 times 7. Now we break down 50. 50, we could do 5 times 10. 5 is prime. And 10 breaks down to 2 times 5. 2 is prime, and also 5 is prime. So the prime factorization of 50 is 2 times 5 times 5. Now we take this fraction, 35 over 50. 35 becomes 5 times 7. 50 becomes 2 times 5 times 5. These 5 simplify out. Your final answer will be 7/10. Now, we scroll down to the next problem. Now we have C and D. Now C, we need to take the prime factorization of 120 and the prime factorization of 86. Now 120, 5 times 24 is 120. So 5 is prime. 24 we could break down to 4 times 6. Now 4 breaks down to 2 and 2. And 6 breaks down to 2 and 3. Now these are all prime numbers. So now the prime factorization here is 3 2's, a 3, and a 5. Now we go to 86. 86 breaks down to 2 times 43. 2 is prime, 43 is prime. So our prime factorization is 2 times 43. So now we take this fraction, 120 over 86. And that gives us, in our numerator, we add 3 2's, a 3 and a 5. And in our denominator, we will have 2 times 43. Now these 2's here simplify out, and you will have 60 all over 43. Now we come here to D. We need to take the prime factorization of 144 and the prime factorization of 324. Now 144, we could break that up. This will give us 12 times 12. And we know 12 could break down to 3 times 4. And this 12 would be 3 times 4. And we know 4 breaks down to 2 times 2. And this 4 breaks down to 2 times 2. Now our prime factorization, as we see here, we have 2 3's and 4 2's. So we have our 4 2's and our 2 3's. Now, with 324. Now, this may take a little bit, but we can do it. We could do 2 times 162. So 2 is prime. And 162 breaks down to 2 times 81. So this 2 is prime. 81 breaks down to 9 times 9. And these 9's break up to 3 times 3. And 3 times 3. So now we have 2 2's and 4 3's. Now, we need to write this out as the fraction. Now, what I'm going to need to do, I'm going to need to move this down a little bit. Okay, to give myself some more room.